There is no question why our planet is called the blue planet. About 70% of its surface is covered by this pretty simple molecule, H2O. And that is good for us and all other life on Earth, because every single organism needs water to survive.
Well, we know water, like all matter, can exist in 3 different states: solid, liquid, and gas. But water is a little special. You see, in between water molecules, there are bonds called hydrogen bonds that hold the water molecules together. And these bonds are actually what give water many of its special properties and affect the whole water cycle.
For the most cases, the solid state of a material is more dense and heavier than the liquid state. But not for water. You see, water has its highest density at 4 degrees Celsius. And below this, the hydrogen bonds start to arrange themselves in ways that the water molecules take up more space. And when water freezes, the crystal shapes that are formed have less density than the liquid water.
The difference in density is actually what causes the large currents here in the ocean. As the water cools, it becomes more dense and heavier and sinks, and warmer water takes its place on the surface. This implication of the hydrogen bonds is of great interest to marine chemists.
By measuring the concentration of certain chemical compounds known as tracers at different depths in the ocean, marine chemists can get an understanding of how different water masses move in the deep ocean. Some of these measured compounds have been transported a really long way for several hundreds of years.
But if enough heat is added to the water surface, certain things start to happen to the hydrogen bonds.
As the sun's heat hits the water surface, the solar energy causes the water molecules to move faster and faster, and hydrogen bonds between the water molecules break. And the water changes state from liquid to gas.
As the water molecules rise, they encounter colder temperatures, which makes them slow down and come together again, allowing new hydrogen bonds to be formed between them.
This turns water vapor back to liquid water, or if it's cold enough, hail and snow.
But the water molecules encounter other things up here too.
For example, atmospheric chemists are finding that particles in the air, like dust and pollutants, can actually affect clouds. It turns out that with these particles, cloud droplets can freeze at higher temperatures than pure water droplets do.
So particles in the atmosphere have an effect on cloud formation and the entire Earth climate system. But how? Well, that's exactly one of the things we're trying to find out.
Well, at some point we know that the water up here in the atmosphere will get too heavy and fall back down to Earth again as precipitation. Time for me to do the same.
Well, most of the water that ends up in our homes comes from this precipitated water, either pumped up from groundwater or from a surface water source, such as a lake or a stream. But we know we shouldn't just go out and drink any water in nature, because during its journey here, the water will also pick up a lot of stuff that could be bad for our health. So water quality has to be carefully analyzed and monitored, both in nature and in water treatment facilities before it's sent to our homes. And this is definitely a really important job for chemists as well.
For example, we make sure the water doesn't contain harmful bacteria, toxic substances or heavy metals before reaching the public.
So we have learned how the water cycle is filled with adventure and chemistry. And one of the things giving water its special properties are the hydrogen bonds holding the molecules together.
Well, heat can break these hydrogen bonds and liquid water changes state from liquid to gas.
And when this water vapor cools, it's the other way around. New hydrogen bonds are formed and the water changes state, back to liquid. The chemical stories around water are almost endless. And the research on this incredible molecule varies from the fresh water we drink to the deepest oceans. So remember, chemistry is all around you.